Hey guys, I'm going to explain to you how to do the two molecular geometry labs that I gave you. The first one you'll see is a double-sided sheet, and originally what you were going to do was to answer these questions, and you were also going to build a model of the shape you see. So since we are not going to be building models, you will skip number 4 on your procedures. So you'll just be doing numbers 1 through 3. So I'm going to do the first one for you, just so you know what you're doing. This is your formula, SiCl4. Silicon has 4 valence electrons, and chlorine has 7. And since silicon can form the most bonds, it's going to go in the middle. And I'll go ahead and form a bond there. I have 3 other chlorines that I need to draw. All right, so now that I've drawn my Lewis structure, I'm going to answer the questions I see over here. So the number of outside atoms, that means the atoms on the outside of the central atom. So that would be 1, 2, 3, 4. And the next question is the number of lone pairs on the central atom. So keep in mind, I'm not looking at the lone pairs on the outside atoms. I'm only looking at silicon, the central atom. It doesn't have any lone pairs, so that's going to be 0. So now I need to figure out what shape this is. Keeping in mind that the number of outside atoms, that also is going to correlate to the number of bonds. Let's take a look at that chart that we created earlier when we were taking notes. So if I look at the chart we made, under number of bonds, I see that 4 bonds and 0 lone pairs makes this a tetrahedral molecule. So I'm going to go ahead and answer this question. This shape is tetrahedral. Is the molecule polar or nonpolar? So looking back at my chart, it says that tetrahedral molecules are nonpolar if the outside atoms are the same. Well, in this example, all of my outside atoms are the same, so it's going to be nonpolar. And then, does the molecule contain polar bonds? Well, remember, polar just means that one side of the bond is slightly positive and one side of the bond is slightly negative. And the fact that these are 2 different nonmetals, they're going to have different electronegativities. The chlorine is going to be slightly negative, the silicon is going to be slightly positive. So since we have 2 different charges, yes, it does contain polar bonds. So you can skip over the teacher's initials, obviously. That would be if you were building the models. I was going to come around and check those. So this grade, you will be turning this into me. I'm not going to count it as a lab grade. We're going to count this as a homework grade. So you'll just need to complete the other 4 examples, and that is how you do that activity. Now we're going to look at the other lab, the other molecular geometry lab. Y'all are supposed to do this one tomorrow, on Thursday. So for this, you are going to draw all of your Lewis structures, and then you're going to answer questions based on the models that I have posted to Google Classroom. So I'm going to show you where those models are located. If you are in Google Chrome and you're on my page, the Chemistry 1 Advanced, you'll notice that I have shared different materials with you on the Stream tab. And you're going to want to go to the one that says Lab Resources. Now, we are not doing the balancing equations lab yet. That will be Unit 6. You are in Unit 5. So you're going to be looking at these 6 images that say Molecular Geometry Station. And we'll go ahead and look at number 1. So if you were at school doing this lab right now, you would be at station 1, and that's where we are in our lab. So let's look back at our lab. The question says, look at the model in front of you, compare it to the Lewis structures in your chart. What is the formula for this compound? So I've got to pick between these 5 Lewis structures, which one is represented by my model. So let's take a look at the model again. Oops. So the model has 3 atoms, and the central atom has no lone pairs, and these atoms are joined together by 2 double bonds. So let's look at our options here. Option 1, that has 4 atoms, 3 hydrogens and 1 phosphorus, so it can't be that. We're looking for 3 atoms. Option 2 also has 4, so it can't be that. Option 3 has 3 atoms, so it might be that. We'll have to look at it in a minute. Let's look at our other options. Option 4 has 3 atoms, so it could be that. And then option 5 has 5 atoms, so it definitely can't be that. So it's either H2S or CO2. To figure that out, we're going to have to draw those. So sulfur has 6 valence electrons. It's bonded to those 2 hydrogen atoms. CO2, carbon's in the middle. The 2 oxygens are on the outside. Okay, so hopefully now you can tell. Remember I said the model had 2 double bonds? Well, this structure has 2 double bonds, so this must be CO2. And then you're going to answer the rest of the questions, like what element does the black sphere represent? What types of bonds are they? Are they single, double, or triple? Is the bond length here shorter or longer, or sorry, is the bond length of CO2 shorter or longer than this model? So you'll have to remember, go back to your slides about double and triple bonds, which one's shorter and stronger. And then lastly, you'll identify the shape. So you'll do that for each station. When you get to the second page, number 2, you're going to be looking at the model for station 2. So back to our Google Classroom, I'd be looking at this next and identifying which one it is. And just like with everything, you're going to either take a picture of your work. You will take a picture of your work and you'll either upload it to Remind or you'll upload it to Google Classroom. So let me know if you have any questions.